So in this video, we're going to go over the practice and review for quiz 8. So first of all, this number 1 says evaluate without using the change of base formula. So we're going to try to get the same bases with both the log and the exponent. So this is going to be log base 4 of 4. And so what we want to think of is what 4 to what power is going to give us 1024. And when we do that, we get 4 to the 5th is 1024. And recall again that when our bases are the same, then our answer is 5. Okay, so with B, same thing. We're going to do the same thing here. Okay, so this time we've got the log base 6 of 6 again, and 6 squared is 36. I know you guys know that one. Now notice with the next one, however, so this is actually going to be a 2 that we're going to pull from here, right? Because those are the same, our bases are the same. And then over here we have our base. Remember, when we take something to a power, it's a base. And then log base 4, so those are the same. So this is going to give us 64. And then 2 plus 64 is equal to 66. So that's our answer there. Okay. So now on this next one, again, we're going to do log base 3 of 3. So what I want you guys to think about is 3 to what power is 9? Wouldn't that be the second? But now if the 9 moves to the denominator, is it going to be a negative 2? It is. Okay. So this is 3 to the negative 2 is 1/9. And if you don't believe me, go ahead and put it in your calculator. Okay. And then over here, once again, we have the same bases, don't we? So we can pull that 3. So we're going to pull the 2 here, and we're going to do plus 3 here. So that's going to be negative 2 plus 3, which is 1. Okay? All right, for our last one, again, we're going to do log base 2 of 2. And 2 to what power is 16? Well, 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So this is going to be 2 to the 4th, right? And then don't forget that we got to multiply by that 200 that's still up there. So isn't this going to be then just this part right here, 4 times 200, because these two, again, cross each other out. So this is going to be 4 times 200, which is 800. Okay? So for the next problem, set of problems, number 2, we have condensing. Okay, so remember, with condensing, what we're going to do is we're going to put our positive numbers in our numerator and our negative numbers, negative logs in the denominator. This one in particular only has positive terms, right? So when we condense it, we are basically going to go log base 4 of 3y times, remember if it was plus, we're going to make a multiplication, right? 12xy, okay? So we're going to multiply that together. So 3 times 12 is 36. So this is going to be log base 4 of 36. Don't have another x, so we just have one x, but then we have 2 y's, so it's going to be y squared. So that's our answer for that one, okay? Now with the next one, remember, ln just means log base e, okay? So we're going to do the same property here. So this is going to be ln. This time, though, we have an 8x, and we're going to subtract the 2, so we're going to put the 2 on the bottom because, again, it's being subtracted. So if it's positive, it goes on top. If it's negative, it goes on the bottom. So what is 8x divided by 2? That is 4x, right? So our answer here is going to be ln of 4x. All right, for our next 3, we're going to expand these, okay? So we're going to step this out, all right? So we got log base 3 of 5, and then we have plus log base 3 of x to the 4th plus log base 3 of y to the 3rd. Now, hopefully you remember that when we have an exponent, we're going to move it out to the front, right? So that's what we're going to do. We're going to make it our coefficient. So this is going to be log base 3 of 5 plus 4 log base 3 of x plus 3 log base 3 of y, okay? So let's look at our next one. So on this next one, again, we're going to now break this out into pieces, right? So we've got a log. So what I want to do first before I even go to break it out into our pieces is simplify. So notice we got a 3 up here and a 9 down there, so that's going to reduce to be 3, right? And then this 4 right there is going to reduce the 6 by 2, so this is going to end up being 2. So that's going to be an x to the 2nd, right? So I'm going to write it out here. So this is going to be log of, now we got x squared on top, and we have our 3 and our y on the bottom. Because remember, again, we're going to reduce things. So you can basically just subtract, y'all, when you have the same base on the top and the bottom, and then whichever number was bigger, that's where you leave it. So if the bigger number was on the bottom, then you leave your base down there with the exponent, or if the bigger number is on top, then you move it up there, okay? So now we're going to go ahead and expand this. So this is going to be log of x squared minus log of 3 minus log of y. Now, there's one more step we can do, right? So we can move this out front, because that's what we do. We move it to a coefficient. So this is going to be 2 log of x minus log of 3 minus log of y. So notice this time we don't have anything that we can reduce, so we are not going to have to worry about doing that first. So we're going to have our log base 3 of a, and then the other two terms we're going to subtract because they're in the denominator, right? So we're then going to get minus log base 3 of c and minus log base 3 of b to the 6th. Now what are we going to do with that 6th? You got it. We're going to move it up to the front, right? So our final answer here is going to be log base 3 of a minus log base 3 of c minus 6 log base 3 of b. Okay? All right, this one says write each expression as a single logarithm, then simplify if possible, okay? So this time we're going the opposite direction, aren't we? So we're going to make this our exponent. We're going to make this our exponent. We're going to move our coefficient to be our exponent. So this is going to be log base 3 of, we've got x to the 5th, because that's what that becomes there, and then y to the 3rd, and then we've got the z on the bottom, because it's being subtracted. So on our next one, again, we're going to move that to be our exponent. Our coefficient is going to become our exponent, right? So now we got a log base 4 of our z on top, right? Then we've got x to the 4th on the bottom, and then we have a y to the 4th on top. Again, remember, if it's positive, it's going on top. If it's negative, it's going on the bottom. Okay? Number 5 says, which equation represents the inverse of the function? So remember, an inverse of a log is a what? An exponent, right? So the first thing we're going to do here is swap our x and y. So we're going to say x equals 5 log base 1/3 of y plus 2 minus 7. So our first step here would be to add 7 to both sides. So this is going to be x plus 7 equals 5 log base 1/3 of y plus 2. Okay, so our next step would be to divide by 5, wouldn't it? You guys got it, okay? So now we're going to take this and we're going to write it in exponential form. So I went ahead and moved all that stuff to the left so I have a little more room to work. Okay, so now we have our x plus 7 over 5, and that's going to be equal to our log base 1/3 of our y plus 2, right? Okay, so now we're going to write this in exponential form. So our base, again, base is 1/3, right? So we're going to say 1/3 to what's on the other side of the equal sign, the power of x plus 7 over our 5. And then we're going to take this y plus 2 and we're going to put it on the flip side of the equal sign. Okay, so remember, we're going to keep our base where it is, and then we're going to take the other two things that are on the on either side of the equal sign, and we're going to flip sides. Okay, so now to finish this, the only thing we have to do is what? Yes, subtract 2 from both sides, right? So this is our function. Okay, and so do you guys see that answer up there? 1/3 to the x plus 7 over 5 minus 2. Looks to me like that's C, guys. Got it right there? Just check every term as you guys are going along. Okay, be very careful. So now this next one says which equation represents the inverse of the function y equals 6 ln 4x minus 2. So here again, we're going to swap our x and y. Let me go over here to the left. Let's start on the left this time, y'all. So we got x equals 6 ln of 4y minus 2. So aren't we going to add 2 to both sides first? We are. So this can be x plus 2 equals 6 times ln of 4y. So now we are going to divide both sides by 6. So that's going to give us x plus 2 over 6 equals our ln of 4y. Now how do we get rid of an ln? we take it to the e power, right, guys? So we're taking both of these to the e power, and that's what's going to cancel that out. So now just remember that e's and ln's are inverses of each other, so they do cancel each other out. That's all. Okay, so now we're going to take it down one more step. So we now have e, come on button, e to the x plus 2 divided by 6, and this is equal to 4y. So our last step would be to divide both sides by 4, wouldn't it? So yes, that's what we're going to do, divide both sides by 4. So let's see if we can find this answer up there. So this would be e to the x plus 2 divided by 6 equals 4. So yep, there's our answer right there. It's A. Okay? And again, check, check, check every single term, guys, okay? That's what you really need to do here, okay? Because the 6 is the denominator here, and it's a plus. And the 4 is the denominator of the whole thing, okay? So be very careful when you guys are checking your answers on this quiz. All right, number 7 says, what is the final value of an investment of $5,000 at 6% interest rate compounded continuously for 8 years? So this is our PE to the RT, or PERT formula, right? So, and that's going to be equal to our final amount. So this is going to be our initial amount is P. And then we're going to take it to the e to the 0.06. Remember, you got to move that 2 decimal places to the left, right? So it'd be 0.06 times our 8. And you can put this directly into the calculator, and that is going to give you 80.37. Okay? And again, E is the second ln button on you guys' calculator, okay? So that was our B. Okay, now let's go down here and look at our number 8. Which statement describes the graph of f of x is equal to the log of x plus 3? Select 2 that apply. So they've already given us the graph here. So the first thing I want to talk to you guys about is, what is this line right here? Isn't this the line x equals -3? And we know that our graph is not going to go left of that line, right? It's going to get really, really close to that, but it's never going to touch that line. So this says which statement describes the graph. So that means we're looking for true statements, right? So let's just talk about our domain first. Our domain is going to be from where? Isn't it going to be from -3 to infinity, because those are our x values? And is this graph increasing or decreasing? It's increasing on that interval, isn't it? Because it's going up all the way, right? Keep going up, 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 right? Okay, then let's talk about our range. So our range is going to be what? This is going down and it's continuing to go up, right? So isn't the graph going down and continuing to go up? So this is going to be from -infinity to infinity, right? Now, when we talk about our end behaviors, as we head right on this graph, where's that graph headed, y'all? It's headed up to what? Infinity, right? Okay, so, and as we head towards, okay, wait a minute. If we head to the left, what are we actually heading toward? Aren't we heading towards this asymptote right here? We are. And then the graph is going to go down then, right, towards -infinity. So now let's talk about what we have over here. It says we're going to select 2 of these. So the domain is, well, we know that's not true because that's not what we have over here. We have -3 for that, right? So that's definitely not a true answer. The vertical asymptote is x is equal to -3. That is true. So we are going to circle that one. The horizontal asymptote, well, there is no horizontal asymptote, is there? No, there is not. So that's not true. And as we head right, the graph is headed towards where, guys? Where's it headed right here? Isn't it headed towards infinity? Indeed. So as we head towards infinity, the graph's headed towards infinity. Now, as we head towards -infinity, where's the graph headed? Well, actually, it's -3, right? Not -infinity. Tripping y'all up here, okay? So, yes, remember, if we have an asymptote, it is going to affect our end behaviors in some way, shape, or form. So this other answer is E, okay? All right, which statement is false? So the interval of decrease, so again, let's talk about this graph. This is so this graph starts at 1, -1, doesn't it? Okay, let's talk about our domain. So our domain is going to be from 1 to infinity, right? And it's going to include that value. Our range is going to be what? From -infinity to -1, isn't it, guys? Okay, so again, when we're talking about is this graph increasing or decreasing? It's going down, right, y'all? So this is decreasing, and it's decreasing on that interval because that is our domain. So is what's written in A correct? It is. Then as we head right on this graph, right, as we're going towards infinity, where's the graph headed? Sure enough, looks like it's headed to negative infinity, right? So that one is also correct. And then as we head towards the left over here, doesn't the graph stop the y value at -1? It does. So that is also correct. And then do we have negative infinity to -1 here for our range? No, we do not. So this is the one that's wrong. This should be negative infinity to -1, shouldn't it? So this is our correct answer because that's our false statement. All right, so on the next one, it says which statement is true about f of x equal to 2 times 5 to the x power plus 1. So let's talk this through first again before we do anything else. So this looks to me like it has a horizontal asymptote, and it should because it's an exponential, right? So this is going to be x equals, sorry, not x, y equals 1. Y equals 1, okay? And that's because of that number right there. All right, now let's talk about our domain. So what's happening with our domain? Are we continuing to head left and right with this graph? You got it. So this is from negative infinity to infinity, right? Is this graph increasing or decreasing? It's increasing on that interval, our domain, okay? And then our range, which, by the way, that's all real numbers, right? So our range is going to be what? So what's happening with our y values? Don't they start above 1? So this is going to go from 1 on to infinity, aren't they? Okay. So that's going to be our range. It's going to be from 1 to infinity. And this one says true, by the way. So that's what we're looking for here. So the vertical, so now let's talk about our end behaviors. As we go right, where's the graph headed? Towards infinity, right? But as we go left towards negative infinity, where's the graph headed? Isn't it headed towards 1? Exactly. Okay, so now let's look at these statements. The vertical asymptote is x equals 1. No, because we have a horizontal asymptote, right? So the interval of increase is from negative infinity to infinity. Yes, we did say it was increasing up here. Isn't that what we said? So that's true. And it said true statement, but let's keep going through the rest. The range is from negative infinity to infinity. No, we said it was from 1 to infinity, right? That should be a 1 there, not an infinity. And as we head left on the graph, what is the graph headed towards? It's headed towards that vertical asymptote again, so that should be 1 right there as well, okay? So which of these was true? That was our B. All right, so this says solve for x. So we're going to do ln of 4x minus 1 equals 6. How do we get rid of an ln? We use an e, right? So we're going to take e to both of these. So when we do that, that goes away. And we get 4x minus 1 equals e to the 6th. And then we're going to add 1 to both sides, right? So this is going to be plus 1. So this is going to be 4x equals e to the 6th plus 1. And then aren't we going to divide both sides by 4? Now you guys can put this in the calculator just like this. Okay, e to the 6th plus 1, and then divide that result by 4. And when you do that, you should get 101.1072. So this is 101.1072. Okay, that's your final answer right there. All right. So the next one says solve for x again, and this one says 9 plus our x minus 16 to the 1/4 power equals 11. So I'm going to subtract 9 from both sides first. That's going to give me x minus 16 to the 1/4 power equals 2. And then I'm going to multiply the 1/4 by the reciprocal of 4 up here as our exponent, right? So that means I'm also going to take our 2 to the 4th. So this is going to be x minus 16 is equal to 2 to the 4th is 16. So then we're going to add 16 to both sides. So x is going to be equal to 32. And that was D. All right, then the next one says, how many years does it take for an investment to double at an annual interest rate of 9.2% compounded continuously? So here, we originally, our formula was A equals E to the PRT, but P doubled. So we're going to say 2P is equal to P E to the, and our interest rate is 0.092. And then we're going to solve for our time, right? So if we divide both sides by our p's here, we get 2 equals e to the 0.092 t power, right? So how do we get rid of that e? We do ln, right? So we're going to take ln of both sides because now that cancels that out. So we're going to take the ln of 2. And when I did that, I got a number that was about 0.6931, 0.6931, and that's going to be equal to our 0.092 t, right? So then we're going to divide both sides by the 0.092. Divide both sides by 0.092. Sorry, I don't know why that did 2 dots there, but... And so when we divide 0.6931 by 0.092, I got that t is equal to 7.5 years. Okay? So 14 says solve for x again. So when we do this one, I'm going to rewrite it here. E to the x plus 6 plus 1 equals 5. So we're going to subtract that 1 from both sides first. So we get e to the x plus 6, and that's going to be equal to 4. So how do we get rid of an e? Remember, the inverse of e is ln, so we're going to do the ln of both sides. So that's going to get rid of that one. So we're going to get x plus 6 here equals the ln of 4. And then we're going to subtract 6 from both sides. So x is going to be equal to the ln of 4 minus 6. So go ahead and take the ln of 4. And when I did that, I got 1.3863. And I'm going to subtract 6 from that. So that's what's going to give me that negative 4.6 right there. Okay? So for this next one, it says if z times 4ay equals b, where a, b, and z are positive, which expression is equal to y? So basically, they want us to solve for y here, okay? So what I'm going to do is I'm going to rewrite this problem down here, and I'm going to do z times our 4ay is equal to b. So now how would I get rid of that z if it's being multiplied? Don't we do the opposite? We're going to divide both sides by z. So that's going to give us our 4ay is equal to b over z. So now let's go ahead and write this as a logarithm because our base is 4, right? So we're going to say log base 4 of what's over there on the right is going to be b over z, right? And that's going to be equal to our ay. So now, what do we do to get y by itself? We divide everything by a, don't we? So we're going to divide all of this by a because we have to divide this by a to get y by itself. Okay, so that's going to be our answer. So let's see which one looks like that. Log base 4 of b over z. I covered it up, y'all. So let me take this off of here so we can see it. There it is. Log base 4 of b over z divided by a. So yep, your answer is D. Right there. All right, so the last question here. The city population, which was initially 21,000 people, has been dropping by 3% a year. In how many years will the population drop below 16,000? So this would be just a normal A equals our starting amount, 1 plus or minus our rate of interest to our t power, right? Okay, so this time, however, we know that we want our 1,600 as our A because that's going to be our final result, right? 16,000, sorry. And that's equal to our 21,000. And if it's dropping, we're going to do 1 minus our 0.03. Now listen, if it says, is it growing, we're going to add that number, okay? So watch that, okay? And then we're going to solve for t here, right? So our first step here would be to divide, after we wrote it, would be to divide the 21,000 on both sides. So 16,000 divided by 21,000, I got was 0.7619. And then 1 minus 3% is going to be 0.97% to the t power. So now we're going to take this and we're going to write this as a log, okay? So the base is the base is the base. So the log of base 0.97 of what's on the other side of the equal sign, our 0.7619. That's what's going to be equal to t. So now we're going to use our change of base formula to solve this. So remember, what's in the base stays in the bottom. So log of 0.97 stays down low, and the log of 0.7619 goes on top. So we're just going to do that in our calculator. and that's going to be equal to our t. So that equals 8.9 years.